Right, starting today, attendance will be taken. Those who are not attending the class regularly, they will be reported to the department. Okay, and please inform others. Those who do not attend the class, the department might take action and remove them from the course if they do not attend it. Okay, so let's continue. Okay. I think we stopped right at this slide last class. I have updated something in this portion and I will upload the file right after the class, the updated file. Okay. So what is design? Design is a process that includes a sequence of steps, and the sequence of steps are done based upon multiple objectives. Okay. So what are these objectives? Objectives could be expressed as maximizing or minimizing some variable. For example, you could minimize the weight, you can minimize the volume or area, or maximize the performance functions like the power output, efficiency, etc. Okay, so these will be objectives, and you can have a combination of objectives like these in your design step subject to some kind of constraints. Okay, so these are design constraints. What are design constraints? Maybe you have a limitation with respect to cost, how much money you can invest. So cost might include manufacturing cost, material cost, labor cost, and so many other things. And besides that, there may be constraints with regard to your design parameters or variables itself. And these constraints are usually expressed as minimum value and maximum value. So in terms of inequalities. And design process will consist of optimizing, considering your multiple objectives and multiple constraints together. Okay, so in your senior project, mostly you will be asked to give your objectives clearly, specify your objectives, specify the product, give the product specification, and in addition, you will also be asked to give the design constraints. So in this course as well, I gave you the project and specifically I have asked for design specifications and design constraints to be given for your connecting rod project. Okay, so I will show you some examples of design constraints. I will also show you some examples of objectives, and in addition, I will also show you how to write design specification with an example. Okay. Mostly you will have certain target values to be achieved. So when you have multiple objectives, let's say we consider the efficiency. So efficiency target values will be there. Whatever the efficiency you are calculating here, based upon it, you can specify target values of efficiency, target values of power, maybe target values of acceleration in the case of automobiles, etc. Okay. So all these should be clearly mentioned in terms of engineering values. If you do not have any values, there is no design involved. Okay. Okay. So some examples of objectives we have already seen above, but again, design objectives or design goals usually involves minimization or maximization of one of the several variables, and you may have combination of variables. So you may minimize or maximize power, area, efficiency, etc. Okay. In most of the designs, you will always have one of the objectives as minimizing the weight, maybe minimizing the volume as well, and maximizing power output. In addition to that, design constraints. How do you specify design constraints? This is in some of the examples given here are for electronic equipment. And here, for example, you are given some device size. Okay. So for example, the size of a transistor, maybe in terms of micrometers, you are given the minimum and the maximum size, and these are the limits within which the size is to be given. For example, W may stand for the width, L can stand for the length. These are geometric constraints or parameter constraints. You may have functional constraints. The output voltage should be within some range. In mechanical engineering, it could be, for example, if you take your cars, it could be the acceleration, velocity, depending upon the functional constraint. Okay, so if you want to, for example, measure the efficiency of your brake system, in that case, you would want to measure how fast the velocity of the car goes from a certain velocity to zero velocity. Okay, how fast and how much distance the car is able to come to a complete brake. So deceleration is an important functional constraint you may specify. Okay, so minimum and the maximum values. So constraints are usually limits. Limits could be based upon products, competitive products on the market. Limits could be in terms of your own goals, etc. Okay. So also there are performance constraints. So these are some examples, and you have to provide values. You can see in all these examples, values are given in terms of minimum and maximum value or limits. Okay. So what are the variables, typical variables in design? So if you take a design of a product, usually it is not just based upon your mechanical variables like geometric variables, performance variables, etc. Sometimes it is also dependent upon manufacturing process and business aspects as well. So all of these, they come together. When we go to design itself, okay. So what are the different control variables you can see? You can see product forms. So we can categorize the variables under product form. You can have material properties. You can have functional properties. You can have manufacturing properties related to manufacturing process, etc. So there are different control variables. When we say product form, what do we mean? Usually it means the architecture. What is architecture? The arrangement of the products in spatial locations and how they are connected to each other. So that is architecture. That is also related to form. Any geometric shapes, they are also related. Surface texture, for example, if you require a very smooth surface for your particular application, especially if you have sliding surfaces, then surface texture is very important. And it may be also important with respect to fatigue properties. So we will see how a smooth surface texture improves the fatigue properties in later chapters. Color may be with respect to aesthetics and looks may be important, or even may be very important with respect to functional properties of the particular product. Okay. Anything else? And anything else related to structure or form will be grouped under product form. Okay. Okay, so further discussion here, design is to formulate a plan for the satisfaction of a specific need, that is the objectives or goals within the constraints, and to solve the problem. So simple example, Again, even if you take a light bulb is a machine. We can think of it like a system which converts one form of energy to another form of energy. You have input and output, and depending upon the laws of physics, you might have some loss of energy involved. Okay, so design not only involves the immediate effect of the product, input and output, etc. It may also involve how to dispose of the materials safely. So you, as a designer, you will be responsible right from the creation of the product to the death of the product and how you dispose of the product. So what does a product design specification consist of? How do we specify? So this particular slide will help you either in your specifically with related to your senior design project or the project which is given here. So what does a product design specification consist of? You will have performance requirements. Under performance requirements could be functional requirements. Functional requirements could be that a specific task the particular equipment is supposed to do. So this is functional requirement. Appearance, reliability, environment. Okay, so anything related to environment on which it operates. Cost, ergonomics, comfort. Ergonomics is related to comfort of the user. Quality, weight, noise, etc. All these have to be grouped under performance requirements, and you will have to give all these variables in terms of values. Similarly, you will have operation requirements. Under operation, how do you install, how do you use it, maintenance, safety aspects, how to operate the equipment, taking into consideration safety aspects. Those also need to be mentioned. Manufacturing requirements, how do you manufacture the particular product? What are the processes to be used? What materials? How do you assemble it? How do you package it to deliver the product? Etc. How many quantities? Sometimes if you are producing in mass quantities, how much to produce? So these are mostly required in commercial environment and delivery date. Acceptance standards. Standards is also very, very important with respect to any design. What is the standard you are going to follow? And standards usually involves standards for materials, standards for maintenance, standards for operation, standards for any functions. Okay, so all these have to be specified here. In case you are creating a completely new product, then patents have to be made before you bring it into the market to protect your product. Okay, in case you are using existing patents, then you will have to get the rights from the patent holder, pay him, and then you can create the product. Finally, disposal is also very important. After your product loses its life, then you will have to give how to dispose of the product safely without causing any environmental hazard, and that will be according to standards as well. So these are the different design specifications that will be required. One example is given. So this is a product design specification for a system you are going to install in a bicycle, so that children, young children, they can learn riding the bicycle. Okay, so some example is given here, and product design specification, you can see materials, what kind of materials, any lightweight material, and you can list them as well. What are the materials according to standards, possible materials. Safety, you can specify standards and maybe more specific with respect to safety of operation. Size, you can see various values are given here, weight, installation, uh, performance characteristics. You can see many values are given in terms of loads, operation speed, etc. Ergonomics, life, life in service. What is the typical life in service? For how long the product can operate safely? Working environment, product cost. You can see a lot of details mentioned here. Okay, so this particular slide again will help you with your course project and also your design project, senior design project. Looking at this particular slide, you can decide what specific aspects are very important with respect to your product, and then come up with a product design specification. And you should mention standards, values, etc. for each of the uh, design control variables. Okay. Any doubt up till this point? No. Okay. So this particular chapter, I might not, let me make sure I'm recording. I might not ask too many questions with respect to your exams. However, it will help you either in your senior design project or also your course project. So go through this chapter carefully, and you can try to come up with a very good design for your case. Okay, so any design process usually requires some kind of innovation. The innovation could be radical in case of very new designs, or you can do incremental innovation. For example, an existing product can be there and you can make improvements to specific parts or specific function. Okay, so that involves some kind of innovation. And usually it is iterative. That means you go in cycles, you do something, then you calculate some parameters, and then you find it is no good. You go back to your beginning stage again, you make some changes, and you do iterative process. You continue the iterative process until your target values are reached. Okay. And usually it also involves decision making. In design, decision making is a very complicated process, and it is an optimization process. What is optimization? You need to maximize or minimize couple of variables subject to constraints. Okay, and it is a mathematical process. We will not go through the methods of decision making in this particular course. It will be more complicated, but I'm just letting you know. So these are some of the steps that is usually done in industries. It is very communication intensive. We have seen that an automobile might consist of 1 million parts or more, starting from your screws, fasteners, and every little part you consider. If you count them, more than million parts. Different departments might manufacture these different parts, or they may buy different parts, and all these parts have to be brought together, and usually it is very communication intensive. If between departments communication is not good, then you may not be able to bring or assemble different parts together. Okay, so it is very communication intensive process. Products should be functional. So whenever you consider design, when you start your design in the first stage, the functional properties or the functionality of your product is the important parameter to consider for your design. Then there may be safety requirements. Reliability is usually what would be the life of the product. It measures the life of the product before it undergoes failure. Then any competitive products, if they are in the market, then you will have to, based on it, consider certain target values. Based upon the target values, you will know how to proceed with the design, usability, manufacturability, and marketable. It should be marketable, and your cost of the product should be as minimized as much as possible, so that you can have some profit. So let's look at a simple example here. This is a journal bearing. What is a journal bearing? A journal bearing looks like this. You will, on the inside surface here, usually some kind of lubricated oil is pumped inside, and through this whole a shaft is supported, so that the shaft can rotate with as less friction as possible. When the shaft rotates, the lubricant between the outer surface of the shaft and the inner surface of this journal bearing will reduce the friction, and thereby help in rotation of the shafts. It will usually, journal bearings are used for supporting your shaft. Okay. The material which you find here in the inside part of the journal bearing, usually it is a sacrificial material. That means this material can be replaced. Okay, and it is usually softer than the shaft material. So to design this journal bearing, what are the different fields that we have to consider? If you look at it, heat transfer, that is one field. If you want to do material selection, that is one field you will have to consider. You will also need to consider in manufacturing, especially thermomechanical treatments. So manufacturing is a separate part. Besides, manufacturing thermomechanical treatment during manufacturing is specifically important for this journal bearing design. Any statistical description about the properties of the material, that is also important. Fluid flow, especially when you have lubricant, that is very important. Heat transfer, why is it important? Because whenever there is some sliding motion between two metallic parts, heat will be generated and it has to be transferred outside. If the temperature increases for the parts too much, then it might lead to damage. So you will have to design the part taking into consideration maximum heat transfer properties. Okay, so there are many other fields also which we will have to consider for journal bearing design. A journal bearing does not even consist of any moving part by itself, because the journal bearing itself does not have any moving parts, but yet you can see without any moving parts how many different fields come together. Okay, so design process is often very involved. We will go through steps in the design process in the slide here. So what are the different steps? First, we identify the need. When we say identification of need, we mean coming up with a design, product design specification. So you will need to identify all the variables, all the control variables with the values, and then come up with target values for specific variables and make appropriate changes in the design. Then we go for the design statement or definition of the problem. The definition of the problem will usually involve maximize or minimize these control variables subject to these constraints, and probably also list what are the target variables to be achieved. So that will be the definition of the problem. Once you define the problem, then we can go for design analysis. So this will be the meat of the portion of your design in synthesis. So here you will come up with new solutions, and then once you come up with the solution, once you know what is the geometry and what are the different parts and what is the architecture of your design, then you will do analysis. So analysis will usually involve heat transfer analysis, maybe experiments through experiments or simulations, may involve stress analysis, may involve functional analysis, etc. And after you do the analysis, you will also try to optimize all the variables. So what is this optimization? To again make it as efficient as possible, whatever you have, whatever design you have, and then if it is not optimized, you go back to your design stage, try to change some variables, again optimize. If it doesn't still work, maybe you rewrite your problem. Sometimes it can lead to rewriting your problem statement. Then once it is optimized, you may have 5 different designs. You may have come up with 5 or 10 different designs, and based upon 10 different designs and certain control variables and target values, you will decide which design is best. So you will choose the best among the designs. There is no correct solution here, but rather you will choose the best design possible. Okay, and then you will take your design and give it to your manufacturing department. So these are the steps in design process. You will see a little bit in detail about these steps here. So we can divide your design into 3 different phases. Phase 1 is conceptual design, embodiment design, and detailed design. What is conceptual design? In this stage, we will not care about what is the form of your product, what is the shape of your product. You never think about the shape of the product at this stage. You think about concepts, how to achieve some particular functional goals based upon physics, based upon pure physics. You will identify how to achieve certain functionality. In embodiment design, what you do is you take your abstract concept based on physics and give it a shape and size and location of different parts in your products. Once you have the embodiment design, once you finalize that, then you go to detailed design where you give the exact dimensions in drawings so that you can produce these drawings to your manufacturing department. So these are the 3 stages. Let's see each stage in a little bit more detail. Okay, so in the conceptual stage, you will define the problem. So under the definition of the problem, product design, PDS stands for product design specification. So before you come up with the product design specification, there are a couple of steps you need to do repetitively. So what are these steps? Problem statement, benchmarking. What is benchmarking? Benchmarking is to come with target values. If you have competitive products on the market, they may have certain performance parameters. You need to do better than that in order to market your product. Okay, so you may have certain target values, right from cost to performance parameters. You may do some product dissection, especially if the product is in the market. You will have to find what are the different parts, how they are connected, how do they perform, etc. So you do a product dissection and then come up with what is called as house of quality. What is this house of quality? So house of quality is a table. Basically, it is a table consisting of all design or engineering parameters in a table that is shaped like a house. And this table will consist of all your benchmarking target values for your particular variables, design variables. And from the house of quality, we will be able to come up with product design specification. So I'm going to go a little bit further here. Let's see if we have an example of product design specification. No. Yes, hold on. Let's open. Let's see here. Okay. So I'm going to open another example file here. So this is an example of house of quality for a car door. Okay, so if you take a typical car door, it will have many functions. So this particular slide gives you in layman terms what are the functions of a car door. So you have primary functions, secondary functions, which further divide your primary functions further, and then tertiary functions. Again, it will give you specific functions of your car door. So let's see an example here. So what are the functions we have? So in layman terms, it should be easy to operate and use, good appearance. That is also very important. So when we say it should have good operation and use, what do we mean? So let's try to further see what it is in terms of in layman terms, easy to open and easy to close the door. Okay, so you should be able to close the door very easily without banging it and open it very easily. It should isolate. So this isolation could be in various terms, from environment, temperature, humidity, noise, etc. So isolation could be these. And it should also provide a very good armrest, especially if you are driving long for very long distances, then it should provide you a good armrest. Okay, so let's see further. How do we divide these functions? Easy to open and close the door. What do we mean? Easy to close from outside. When you open it, let's say we are uphill, we are going up above a hill, we put on the brakes and then we try to open the door. It should not close automatically. When you open it, it should stay open. Easy to open from outside, easy to close from outside, doesn't kick back, easy to close from inside and open from inside. Okay, so this is easy operation. Further here, isolation, you can see it does not leak during raining, no road noise, doesn't leak in car wash, no wind noise, especially when you are going in high speeds, doesn't drip water or snow when open, doesn't rattle, especially doesn't vibrate when you are traveling. So these are some of the functions. Armrest, soft, comfortable, right position. So there are multiple functions. Starting from simple layman terms, when we think about it, we can come up with multiple functions for a car door. Similarly, again, in terms of appearance, we have multiple functions. So this is in layman terms. We have to convert all these properties into engineering properties which are measurable. So how do we do that? Okay, so I'm going to, before we go there, these are customer ratings on each of the requirements. The customer requirements, how important it is for them on a 1 to 10 point scale, and they have given their rating, and these ratings are also very important. Here we have customer evaluation of the competitive products. So these are target values. Again, all these have to be converted into some kind of engineering properties. So here, what we do here, this is the house of quality. So let's see the shape of your house of quality. This is the table and looks like a house. So therefore it is called as house of quality. And you have different columns, different rows here. So we will go one by one. So typically you can see here, you have all the customer requirements listed, customer attributes. So these are written in terms of a layman person, and we cannot directly use these properties in your design. So what do? We translate these properties into engineering characteristics. Okay, so how do we do that? For example, energy to open the door or close the door, etc. So energy, in terms of how much energy is required, we try to come up with some values. Check force level, check force on 10-degree slope, etc. So you have several properties here. In terms of engineering properties like force, energy, okay, any frictional force that exists in opening and closing the door, etc. All these have to be measured and then written as engineering properties. So the same layman properties have to be converted into engineering properties here in this section, and then we have this complete table with the customer perceptions on the side. Okay, so how do we fill in this table? So in each of the rows and columns here, we will fill some values corresponding to the engineering properties. We can fill the values, and we can also check whether those particular properties have been satisfied in our design with a tick mark here. And you can see here below, all the force values are given. Okay. All right. So finally, we have the form here. On top of this, we also have a table which is shaped like a roof. What does this do? Sometimes two different properties, two different engineering properties may be related to each other. If you increase performance with respect to one property, it will lead to reduction in the in a related property. So sometimes these kind of things happen, and in your design you will have to compromise between the two properties. Okay, so always, not all the engineering parameters are independent, they may be inversely related, and when they are especially inversely related, engineering properties are inversely related, then you are in a little bit of trouble, and you will have to optimize or compromise between those properties. So this is what house of quality looks like, typical house of quality, with all the values, with all the target values to be achieved, etc. They are, you can see here, target values are given here with the customer's evaluation of those properties, and based upon these target values, you give your problem statement. Okay, so I will post all these files in your Teams. You can go through that. So once you define your problem in your conceptual design stage, then you look for existing products. Are there any existing patents? Are there any products on the market already? And you will have to gather more information about that. And you may also get your benchmarks for your particular design. And finally, you come to the concept generation stage. So in the concept generation stage, what do? You create what are called as functional models. How do we create functional models, or what is functional model? Based upon your product design specification and problem statement, there may be some functional requirements, main functional requirements, and you will write it as a block diagram. We have seen earlier how to represent a block diagram, especially as input and output. So you will represent it as a block diagram. Some input energy, you do some function, and then it gives you some output energy. Okay, so by creating these block diagrams, you will be able to think about different physical principles by which you can achieve this function. So I will go through an example problem here. Okay. So what is brainstorming? Brainstorming will usually involve a team of members coming up with certain solutions for your functional models. And we will try to do an exercise here right after I finish these slides. Once you come up with different solutions, okay, so the function can be usually split into several functions. We already saw an example here how we split one function into several functions here. So in the same way, we can split existing function into several simpler functions, and for each function we can come up with a solution. So through this we will come up with several solutions, maybe not just 5 or 10 different designs. By combination of designs, you may come up with 25-30 different designs. Okay, and it is very easy. For example, if you take easy to close from outside, when we take this particular function, each person can come up with one or two design concepts based upon physical principles, how to achieve this particular function. When you have 5 different members, maybe you come up with 10 different solutions for here. Similarly, for each of these functions, you may come up with 10 different solutions. When you have, how many functions we have? About 5 to 6 functions, and each function has 10 different solutions. You can see here we have different combination of solutions already. 10 times, 10 times, 10 times, 10 times. So we have several solutions already. So we may choose some of the solutions, and then based upon those solutions, we will select a particular solution which satisfies your design to the maximum possible extent. And how do you do that? Again, if you take a look at the house of quality, you have all these values, and you can evaluate your design based upon all these engineering properties, give it some number, and then we will be able to figure out whether our design satisfies the target values or not. And based upon it, we can make a decision. So this is your conceptual design phase. In the conceptual design phase, we do not think about the shape of the product. I have already mentioned this before. Once you finish the conceptual design, you have some abstract idea. From the abstract idea, you start giving shape to the design. Here, what we do, embodiment means giving a body or shape to your idea. So here we start with what are the different physical elements that need to be used in your design. For example, you might decide to use shafts, gears, pulleys, things, different parts in your design. So you have to think about different parts that you may use in your design and how to bring them together. What should be the size of each of the part, etc. And what are the manufacturing processes? All these you need to think about in this step. You will also use design for manufacturing, design for assembly, and design for environment here. So what are these? Your whatever parts you are designing, it should be manufacturable. Okay, so therefore you have to think about design for manufacturing. Design for assembly means ease of assembly. You should be able to easily assemble different parts for maintenance purpose and disassemble them. So modularity in your design. And then you have design for environment, especially when you use harmful chemicals in your product. For example, if you take your batteries, you have acid and different harmful chemicals. You cannot just throw the battery away. You have to think about how to dispose of the material safely, and any tolerances. So we will learn about tolerances more later. And finally, in detailed design, you produce the drawings to exact specification. Okay. So I'm going to skip here and let's go here. So what are some of the some of the properties or characteristics that are important in design? These are listed here. So this particular slide helps you to identify what are the design variables that are important in your design. Functionality, strength and stress properties of your material and your particular design. You have to calculate your stress, distortion, deflection, and stiffness, very important. Wear properties, corrosion, safety. Okay, you must also come up with methods to to calculate the reliability of the product, whether your products are manufacturable, cost. If you have sliding surfaces, you have to consider friction. Maybe you should make it as lightweight as possible. What will be the typical life of the product? All these calculations must be done. So all these are important. So some of the important characteristics are listed here. And whenever you design, go through this particular slide. So let's go for an example of conceptual design. So what is the problem you have here? You have a wine bottle or whatever bottle you wish to have, juice bottle. It is sealed with a cork. You are to design a cork remover. So this is the cork, a cork remover. Or maybe you are to design some particular product that will facilitate taking this liquid and pouring it inside the glass here. Okay, so how you do it, I don't care. Okay, you are to design something that will facilitate the transfer of the fluid from the bottle to your glass. So how will you do that? Are you guys listening? So how do we start design? Yeah, so how do we do that? In conceptual design, I told you, you come up with abstract ideas based on physical principles. You do not think about shape of any product. How do you achieve this particular end? So how do we do that? Based on physical principles. Physical principles may be applying forces, applying twist moments. It could be any physical principle like that. So how do we do that? Can any one of you tell me how to achieve that?
Maybe applying force with a twist.
Force, applying a force with a twist. Where do you want to apply it?
In the top of the.
So on the cork of
Yes.
the bottle. Yes. So you apply a force and twist. Where do you apply the force? On the top, bottom, on the side. Where do you apply it?
On the top.
On the top. Okay. So the first solution, physical, based upon physical principle. So you can see here, one of the solution is to apply a force on the top. How I apply it, I don't think about it. I am just thinking about physical principles. That's about it. Okay. So in the first solution, apply a force on the top. Okay. Any other solution? Maybe you apply a twist on the top as well. Both of them together. Okay. So any other solution?
Maybe break the top.
Break the top. Yeah, that is a solution. Break the top. We don't think about whether we have a good solution or a bad solution. We just think about physical principles. Okay, so you can break the top of the bottle. Another solution. Any other thing?
We can shake it so it has some pressure and maybe it's explode the top.
Okay, but usually, yes. So we can think about it as shake. We shake and maybe it explodes. One of the solution. Yes. Then any other? Just physical principles. Think about physical principles. Don't think about how it happens. Only physical principles.
Maybe doctor making a hole in the crock and letting the liquid out.
Okay, making a hole in the cork. Okay, that's a good solution. Yes. Any other solution? How about we apply the force on the side instead on the top? We can apply on the side. Maybe we can apply on the inside. How do I do it? I don't know, but that is also a physical principle. If I apply a force inside, it will push it outside. So you already, one of you told me that by shaking the bottle, it creates pressure, maybe release of gas, and then produces a force inside, which pushes the cork outside. So again, we can go to a very general case by applying a force inside. How I apply it, I don't think about it now. So this is also a physical principle. Okay. Maybe I pulverize the cork. Somehow I'm able to break the cork into pieces without damaging the bottle. So that is also a method. Okay. Okay, so now we have physical principles. Apply the force outside, apply the force inside, apply the force on the sides, pulverize the cork, break the bottle. Okay, so some of the methods. Now, in the conceptual stage, we go to the next stage. How do I apply these forces? Where we apply it? So, first solution. Let's see. It takes some time for the pictures to come up. I don't know why. Okay. Okay. So first, we take the part A, and we will think about how to apply the force on the top. Okay. So one of the way, what we see here is to penetrate the cork using some kind of a drill, and then or some type of a screw, and then push it outside. Okay, pull it outside. Sorry. So this is one of the method. Okay, so this is one method to create force on the outside. Is there any method, any other method to produce force on the top surface here? Any other method? How can we produce a force on the top? Are you guys listening?
Yes,
Yes, doctor, but I don't have an idea.
same.
So think about it. Don't think, no, you can think about it. How do we create a force here? A force which acts outside. Maybe we use an adhesive, something that can stick to the cork and pull it outside, right?
Yes.
Maybe.
Yes. So what other methods? Are there anything else?
Doctor, maybe we can use a pressure.
Yes, that's a very good idea. So I can put some box around this, create a vacuum on the top. So that means here I will have very high pressure, a vacuum on the top, very, very low pressure. Automatically force will pull it out, correct? So that is
Maybe
another
putting it upside down
upside down.
and
All the,
pulling it from the bottom, maybe.
yeah, if you pull it, maybe the fluid will all spill upside, right? Yeah, but That is also a solution, but we see maybe the fluid will spill. Okay. Okay, so we have a couple of solutions on how to apply the force on the top. So let's go to the other guy. How do we apply the force on the sides? Or how do we apply force on the bottom? So if you think about it, force on the sides, maybe we put something on the side like this. We have a hollow cylinder which forces its way between the surface of the bottle and the cork outer surface here. Twist it and then we'll be able to pull it out. So this is probably a solution. How do we apply a force on the inside? Maybe we have a small syringe, we put it inside, we apply some gas pressure from outside, increases the pressure inside, and that will apply a force on the inner surface, and then the cork comes out. So some solution based upon simple physical principles. Next step from this stage, in the next step we are still in the conceptual stage, we go for the shape of the approximate shape of the product that could achieve this. Okay, so let's see here. It's taking some time to upload the figures. I don't know why. Okay. All right, so here you can see in the case where I apply the force on the top, how to come up with a shape of the product, how to apply the force. The force can be applied on the top using various methods. One is applying the screw. Directly you apply with the hand. And if a young person, let's say a child comes, he may not be able to apply the full force. And if you want to design something which can be used by a young child as well, maybe you should use some kind of a lever principle so that you can apply the force very easily. Okay, so this is applying some kind of a lever principle. Again, here we use some kind of a screw mechanism, just like your car jack, where if you rotate this slowly, the cork is pulled out with lesser effort. Here we have a spring system, again, to pull it out. So again, different designs. You have direct pull, lever assisted pull, gear assisted pull, spring assisted pull. Okay. So you can see here already we have come up with several designs here for your system. A simple cork remover has several solutions. So you can think about complicated products, how many solutions you can come up with. So this is how you do your conceptual design. And especially if you want to come up with the embodiment design for your product itself, and you have to come up with a shape, you will have, most probably you can come up with several shapes for your design based upon your conceptual design ideas. So when you start your design, usually you start with physical principles. You do not think about the shape of your product, and then you think about the shape of the product at a later stage. When you do this, you will come up with more ideas, much more ideas than simply coming up with a specific shape of the design. If you start thinking about the shape of your product right at the beginning, you will be stuck with one particular design and you will not come up with many solutions. Okay, so this is why the process of design is very helpful to increase your creativity. Okay, so this is a simple example. Again, you can see this block diagram here. You want to generate a force. What kind of a force? Force could be direct pull, levered pull, geared pull, direct push, levered push. And for each of this, you have different solutions, how to transmit the force. You do it through a shaft or a linkage, or maybe a gas injection, and then you apply the force through the linkage. So all these block diagrams and the physical principles through which you can achieve a certain function can help you in your creativity. So once you are done with your design, then you will have to do what is called as analysis of your design. Okay, so what is this design analysis? It could consist of all these particular functions. Analysis for stress and strength. Usually all your failure analysis takes place here. Analysis for stress and strength. After you do that, in some places you may also need to do bending analysis. For example, if you take your aircraft wings, bending analysis is very important here. And buckling analysis is also very important. Analysis for torsion, analysis for buckling, analysis for contact loading, especially if you have two different parts coming into contact with each other, like two gear teeth in contact. So their contact loading is very important. Especially if you have combined loads, then you will have to think about how the combined load acts on your product. And if it is possible, instead of having combined load, if you can distribute this load between different parts with a single load, that will be better, because it will increase the life of your product. So you should try to avoid, as a design rule, try to avoid application of combined load. And if you cannot avoid it, then you can go ahead with it. Otherwise, you can split the loads between different parts. You should always prefer, as a design rule, to have tensile or compressive loads in comparison with bending loads. If you can avoid bending loads, you should avoid it. Okay, it's better to have tensile and compressive loads rather than having bending loads. So these are some design rules, basic rules you might have in your mind when you are designing some product. It is also better to avoid any cyclic load if possible. Otherwise, you will have cyclic load. And in case of cyclic load also, it is better to have tensile and compressive loads in comparison to bending loads. Again, when you have cyclic bending loads, the product will break faster than the cyclic tensile and compressive loads. In some cases, products operate at very elevated temperatures. So then in that case, you will have to do creep analysis. And if you have cyclic loading, then at elevated temperatures, you will have to do analysis here. So in most of our case, we will not deal with elevated temperature, loading at elevated temperature. But in many applications, like your aircraft propellers, for example, or your IC engines, or your let's take the example of power plants where you have gas turbines, etc. Elevated temperatures of operation are very normal there, around 600-650 degrees centigrade, and at those temperatures you will require completely different type of analysis. You will have to do creep analysis, and if you have cyclic load at elevated temperatures, again fatigue analysis, leading to fatigue failure faster than at room temperatures. So at these temperatures, we usually use very special materials. Analysis for resonance, extremely important for all moving parts. Whenever you have a moving part like shaft or any vibrations that those are involved, and resonance is a very important phenomenon. Have you guys heard of resonance? Are you guys
No.
there?
No.
Okay, so did you guys take any course on vibration
This course, this semester.
this semester? You are going to learn what is resonance. Resonance is a property of a material where the frequency of the vibration due to externally applied loads, where if it matches with the natural frequency of the material, then it will lead to abnormally large, very large vibrations and failure. Okay, so we always need to avoid operating at resonance frequencies. So let's see an example here. I'm going to show what resonance does. So let's see, Tacoma. This is Tacoma Bridge, which was designed US. Can you guys hear the one? I think I will avoid this. I want to have some. Can you hear the volume from my screen?
Yeah, we can hear it. It's
Yes,
too
doctor.
loud.
Okay, so I'm going to play it now. Okay, so just watch.
Tacoma Bridge, Washington, opened only a few months ago, was built at a cost of over $6 million. But misfortune overtakes the great structure. These are some of the most amazing pictures ever recorded by a newsreel. The actual collapse of the world's third largest suspension bridge. Only a 35-mile-an-hour wind is blowing, but this apparently sets up a rhythmic swinging of the bridge, which increases with each swing. Finally, the swinging road and the suspension cables give way and plunge into the water below. Fortunately, the only casualties were a car stalled on the bridge and a dog.
Okay, so this is an example of what resonance frequency does. The bridge was not designed taking into account the wind speeds and the natural frequency of vibration of the material of the bridge. Okay, because of that, what happened when the wind speed matched the resonance frequency of the material of the bridge started vibrating violently, and then the failure took place. You can see here. So the same type of failure will take place in any moving part when you have the externally applied load in such a way that it matches the natural frequency of the material. Okay, so this is called as resonance frequency, and we will see in the later stages of your course here how to calculate resonance frequency for your shaft. For example, shaft is rotating, and there are formulas through which we can calculate the resonance frequency of the shaft, and we must avoid operating at those speeds. If you operate at those speeds, it will lead to violent vibration and immediate damage in your particular component. So did you get the conceptual idea what is resonance?
Yes, clear, doctor.
Yeah,
Okay.
yeah.
So again, we have thermal effects. Okay. So with respect to your senior project, especially if you have moving parts, resonance frequency is very important, and this question will definitely come up. Okay, so you will have to do the calculations for resonance frequencies and show it that you have considered in your design. All right. So again, you can see there are so many different types of analysis. If you have fluids, then you will have to do for fluids. If you have magnetic field, gravity, any fluids which are acidic or alcoholic based upon pH values, they also need to be taken into account. If there is radiation, you have to take into account radiation, especially in nuclear power plants. When you design your structure, radiation is an extremely important part here. If you are designing very small systems where you need to take into account, for example, van der Waals forces, electroweak forces, those come into effect. If you have sensors, control systems, then you have to take that into account. If you take your cars, for example, when you are designing your car seats, ergonomics is very important. What is ergonomics? It is a separate field which takes into account what is the comfort level for the user. So whenever you are driving very long distances, your car seat should support in such a way that it does not lead to backaches or some kind of spine damage for the driver. So you have ergonomics is very, very important here. Manufacturability, and you can see so many different analyses are there. In a commercial environment, you will consider different types of analysis for your design. Okay, so the analysis procedure could be different procedures. You can do it with manual calculations, analytical calculations or closed form solutions. So in some cases, you can get calculations and you will be able to solve it with your manual calculations. In most of the cases, you are going to see that you cannot do calculations manually. So what do? We use some softwares, especially we use finite element analysis softwares. There are different types of softwares available, not just finite element analysis softwares. You might have softwares for material selection. You might have softwares for dynamic analysis separately, especially when you bring in different parts together. There are specialized softwares available. There may be experimental procedures are also that could be combined, especially if you are creating a new product on the market. Experimental procedure will be a necessity there, because you cannot depend just upon simulations. We do not know whether those simulations and mathematical models where we use in the simulations are reliable, and we do not know that, and we have to experimentally test your product and then confirm the results. Okay, so up till this point we have seen analysis part. We also need to discuss briefly about standards to be used. How do we access the standards? So what are the different kinds of standards we might have? We may have technical standards, environment related standards, quality assurance standards, etc. Technical standards are related to your design, geometry, something related to your dimensions, something related to performance parameters, etc. So technical standards. Environmental related standards are usually related to usage of harmful products, just like battery, chemicals, and all these. How are they to be disposed of? Those will be related to environmental related standards, and most of the countries will have legal implications here. So you will have to specify the standards there. Quality assurance standards usually involves what should be the quality of the product. Again, there will be certain engineering parameters, and quality assurance standards give you guidance with respect to the quality of the product. Let's take a 15-minute break, and we will come back at 9:35, and we will continue here. Try to finish this chapter and I will also show you how to install ANSYS student version when you come back. Okay. So let's meet again in 15 minutes. Is that okay?
Okay, doctor.
So I will
Doctor,
meet, yeah.
what is the software we have to download for this course? Is it
I will
SolidWorks?
show when you come back. The first thing I'm going to show you is finite element software, which is available for free, student version. You can download that and install in your system. Okay.
Okay.
Okay. So I'll meet you guys in about 15 minutes, 9:35. Okay, can you guys hear me?
Yes, Doctor.
Yes, Doctor.
Yes.
So we will finish this from this part of the slide later. I'm going to show you how to install ANSYS student version. First, go to Google and type ANSYS. If you are there online, try it right now. Okay, type ANSYS, type student version. Okay, version, and it will automatically come up. Once you click on that, the very first link will take you to ANSYS student version. Okay, you can see free student software downloads. Okay, you have three different options here. You will choose the very first option, ANSYS student. Okay, so let us see here. Let's read both of them. So ANSYS student is our ANSYS workbench based bundle of ANSYS mechanical, ANSYS CFD. CFD means computational fluid dynamics. ANSYS mechanical usually involves the solid mechanics, anything related to solid mechanics. ANSYS Autodyne, ANSYS Space Claim. Space Claim is your front end or the graphical user interface to produce your models. For example, you can create the geometry of the product using your Space Claim and also ANSYS Design Explorer. So this is the one you want to install for your system. So you can click on download now and it will automatically download and then follow the instructions given for installation of this particular version, whatever you are downloading. Usually the student version will be valid for 1 year from now. From the time you install in your system, it will be valid for 1 year. And there is also this discovery. I think it is a slightly different one. So this is based on simulation technology. Student is our next generation product design software. It has integrated geometry modeling, Space Claim, completely meshless and instantaneous thermal, structural, fluid solvers. Okay. So which one is there? Here we have CFD, mechanical CFD. Looks like ANSYS Discovery has more functionalities. So either of this you can install. Okay, either the ANSYS student version here or ANSYS Discovery. I think Discovery has much more functionality with this. And here you can see, in addition to CFD, fluid solvers, you also have structural solver and thermal solvers. And you still have the Space Claim where you can create your product. So try to download Discovery here. I would prefer probably this one, ANSYS Discovery student version, and try to install this. Check also validity of the software after you install, whether it is valid for 1 year or 6 months or whatever is the timings. So once you install here, then in your Windows, I assume all of you have Windows. In case you have a MacBook, or I don't think you will have Linux. If you have a MacBook, then you cannot install your software here. It has to be installed. The free version is only available for Windows. Okay, so please, if you don't have Windows, if you have a MacBook, create a partition and create your Windows operating system, and there you can install the Windows version, free version there. Once you do that, you can click on the Windows here, start menu, and when you go down or go through your programs which are installed, you can see ANSYS version that is installed in your system. Click on that. It will expand. And if you go all the way down, you will see what is called as workbench. This is the place where you start creating your models. Click on it. So if you click on it, it will take some time to open. Wait for it. And you will see this window coming up. Still it is uploading. Okay. So once you install in your system, you might have some issues. If you have some issues, for example, on the left pane here, so this is the workbench you have. On the left pane, you will have all the toolboxes. For example, you might see your fluid solvers, your structural solvers, and thermal solvers, and a couple of other things. So on the left hand side, you might have some problems in the display. Maybe the solvers are the letters what you see here are very small. In case it is small, let me know. I will tell you what to do. Okay, after you install it in your system, I will let you know what to do to fix certain things. Once you fix it, then you are ready for your ready to use your system. Okay, so for example, here on the list of solvers, you have the fluid solver, and if you go all the way down, you have structural optimization related to your structures, and you might also have transient structural system, transient thermal system, anything related to structures you can see on the left hand side. So let's see here. You have static structural system. So what is a static structural system? You want to solve a problem on statics, not on dynamics. Then you will use static structural system. If you want to solve a problem which is time dependent problem, something is moving, then transient structural system. That is what you will use. So let us see the example of static structural system. I have selected that. Left click on the static structural system. Keep the left click down. Don't release it. Drag it, and you can see the square on the window here. Release it there, and then you will see the model create. Okay, so here what do we do? First section here involves all the materials. The materials are already selected for you, and the particular data is available. If you double left click on that, it will open up a system where you can see what kind of materials are selected for your model. So usually by default it is structural steel with the properties of density of the structural steel, isotropic elasticity, Young's modulus. You can see here 200 gigapascals, 2 times 10 power 11 pascals in SI units, and you can see all the other properties listed here. For example, the SN curve, something has to do with, it has to do with your fatigue properties. You also have strain life parameters, again with fatigue properties. Thermal coefficients, you can see what is the coefficient of thermal expansion. You have the tensile yield strength. All these properties are listed for the material. Again, you have here on the left hand side physical properties, all kinds of physical properties and mechanical properties are listed. You can see all the values. Okay, so usually to start with, you do not want to mess with the material properties here, leave it. Okay, so the engineering properties are fine. I hope I didn't change anything. Why does it say Update. Let's see. Maybe I accidentally deleted something. So what I'm going to do is redo this. Let's see here. Let's do that. Delete this part. So I'm going to redo this static structural, and you can see a tick mark. If you do not change anything, don't mess with this particular engineering data. Accidentally, if you delete it, recreate the same model again. Then you have something called a geometry. Okay, either you can double click on that or right click, and you can see a menu appears when you right click. New space clean geometry, click on it, and you will see another window that will open up. So wait for it. It is taking some time to load and open the new window. Let's see here. Oh, that's not open. You can see here starting space clean. Usually it takes a little bit of time to open it up. So once it opens up, you can see here the window for creating your space clean model. Again, you can see both the workbench, WB stands for workbench here, and then SC stands for space clean. So this is the window in which you will create your models. Okay. So
Victor,
yeah, go ahead.
so we won't use Inventor in this course?
We won't use what?
Inventor.
I would prefer ANSYS. Inventor doesn't have that much functionalities as ANSYS. Okay.
Because
so
we aren't used to ANSYS yet. We haven't studied it.
I'm going to show you how to use it.
Okay, thank you.
We will go through the procedure on how to use the ANSYS. So here I'm just showing you the preliminaries. This much you should, once you install the ANSYS in your system, this much you should be able to do, and you should be able to see your menu and this window in your system. So these two should be available for you. If it is not there, if you see the menu is extremely small and you cannot fix it, please let me know. I will tell you in the class what to do to fix everything. Okay. So I'm going to stop right here. We will meet next class and continue with the lecture. I will finish the first chapter. After that, we will see step by step how to use ANSYS. So in the next class, I want you guys to install this in your system and let me know if you are able to open it and you do not have any problem with these windows. Okay. Any doubt up till now?
No, thank you,
So
Doctor.
we download the Discovery, right, Doctor?
Yes, download Discovery and install in your system.
Okay.
Okay. All right. All right. So meanwhile, even if you have any problem, you can just send me a message by Teams while installing if you have any problems, so that I will know ahead of time what is the problem you have, and in the next class I can give you the solution. Okay. All right. So see you guys, and I will meet you again on Thursday. 8 o'clock. See you guys.